I know you want to deploy your own cryptocurrency and maybe create the next Dogecoin. So welcome to this tutorial, guys, and in this video we're going to show you how to deploy your own cryptocurrency at a beginner level. Okay, we are going to take in consideration all those first steps and deploy our first cryptocurrency using REMIX. So with no further ado, let's quickly jump into this video and deploy your own cryptocurrency. So just as I said previously, we are going to use REMIX to deploy to write the smart contract and deploy our first cryptocurrency. So all I'm going to do is to come here to the Google search and type in REMIX, and it's remix.ethereum.org. Okay, and let's wait for it to load, and it might take some seconds, but that's not an issue. But yeah, here we go. This is how it looks like. Okay, this is how the IDE looks like. We have text, we have scripts, but we are interested in this case in contracts. Okay, and we have my first.sol. And so all I'm going to do here is to leave this as the way it is, or delete it. Okay, let me just delete it and create a brand new one. Okay, so here I'm going to have here inside of contract, I'm going to create a new file, and not a workspace but a file. Sorry, it's right here. I create a new file and I'm going to call this my token.sol, just like this. Okay, and here, first thing first, it's SPDX license license. Yeah, I think it's I've forgotten, I think it's license. Yeah, this is SPDX license identifier. Yeah, I think it's that identifier. And here we're going to put unlicensed and unlicensed. Okay, just like this. So next line, let's see, there's an error here saying source file does not specify required compiler version. Okay, yeah, this is kind of normal because this next line is going to be pragma solidity. Okay, and the version is going to be the 8-ish version, so we're going to put 0.8.0, just like this. Okay, and here we're going to have contract. I'm going to say contract my token. All right, contract my token. We initiate the contract just like this, and everything is going to come inside of this contract. But let's first fix this error that's saying SPDX license identifier not provided in source file. So let's see, SPDX license identifier, is it unlicensed or unlicensed? I mean, I really don't know, but we're going to figure that out. Okay, and I think the main issue here is that maybe I've put these ones are supposed to be not in uppercase. License identifier, just like this. And let's see. Okay, we're going to come back on that later, but I think there is a typo here. It either has to be unlicensed or there is a typo right here, but for the moment that's not the big issue. So all I'm going to do here is to import, okay, is to import the Open Zeppelin source file. Okay, and you import Open Zeppelin /contract /token /ERC20 and /ERC20.sol, and this is a Solidity file that, that's the real Solidity file of creating an ERC20 token. And since that has been developed by Open Zeppelin, there's no need of us repeating the same story or recreating the wheel. So if you're asking yourself what is Open Zeppelin, so let's just go to GitHub, okay, and search for Open Zeppelin. And basically they have developed ready to use contracts, okay, for creating tokens, for security, libraries for security and all those stuffs. So we are in Open Zeppelin contract. You enter in contract, okay, and here we're going to go to token. So inside of token, you see the ERC25 folder. Okay, we go inside and here's the ERC20.sol, okay? And this is the solidity files that define all the behavior, all the behavior of this ERC20 token implementation, okay? And instead of rewriting this whole thing, what we have done is to import this ready to use file and just initiate it, okay? And if you see this path, you see contract token ERC20, and you come back here, it's the same, okay? Contract token ERC20 folder, ERC20 file. So all we are going to do here is to say constructor, okay? Constructor, and this constructor is going to have something inside, but before we do that, we have to say that our contract should be an ERC20, okay? We do inheritance from this ERC20 right here. All right, so we have an error here. Okay, let's ignore that for the moment. But what we have here is we are saying our contract should inherit all the functions from the ERC20, from the ERC20 contract that we saw, that we have just seen on the Open Zeppelin repository, okay? And so what you're going to do we are going to utilize the constructor, and we are going to do, let me just show you what you're going to do here. If we go to Open Zeppelin, since this is what we are using, okay, you'll realize that we have a constructor right here. Just a sec. Yeah, it's right here, okay? You have a constructor, and in the constructor you pass in the name, okay, the name of your token and the symbol of your token, and that's what you are trying to do right here. So you're going to say constructor ERC20, and we pass in the name of our the name of our token and the symbol, okay? So in this case, you allow me to pass in the name of my YouTube channel as the name, okay? We have Markim Dev, and the symbol we can say MKD, okay? MKD to mean Markim Dev. And this way we have initiated our token. Congratulations, you got your first token, okay? And that's how it's basically done. It's that easy. And this is becoming easy because we have inherited from ERC20.sol, that is from Open Zeppelin, and they have implemented all the methods and all the functions we need to use. But one thing we are going to do, or one thing you should be aware, when you're creating a token, we have a fixed size supply and I think a dynamic size supply. So fixed size supply means when you're creating your token, you say we are only going to have 10,000 token, okay, and we'll never add on top of that. Or maybe you might say we are going to be adding 10 more token whenever someone pays, or whenever someone sends $100 to our contract, okay? And that's basically the idea behind. But let me not overwhelm you, since this is, a beginner level tutorial. So I'm just going to show you how to create a fixed size, okay? A fixed size supply. So here, and the constructor, basically whatever is passed in the constructor will only execute once when we deploy our contract. So here, only when we deploy our contract, we are going to mint, okay? And basically this mint function comes from the Open Zeppelin, okay? And let me just see right here if I'm going to see it. Mint, a second, we have total supply, we have transfer, we have allowance, but I'm looking for mint. Just let me just quickly see. We have transfer, this is transfer, but yeah, mint is right here, okay? Mint is right here. We have function mint, and you mint, in that function you pass in two parameters, the account, okay, and the amount. So which amount do you want to mint? And as you can see here, we see account shouldn't be address 0. So basically the account shouldn't be the empty address. So in our case, we are going to say we are going to mint and a certain amount of token to the person deploying the contract, okay? And the person deploying the contract is message.sender, okay? And this message, okay, this message object is available in Solidity, and you can access message sender. We have message value and all those stuffs, but the message sender is the person deploying the contract, okay? And you're going to say we want to send that person 1000 tokens, okay? And there is something you have to be aware of, is that in Solidity doesn't support commas, okay? That means it doesn't support floats. So to turn around that, you have to put decimal places, and in most cases for ERC20 tokens, each token has to have 18 decimal places. So we are going to say times 10, okay, exponential 18. So this means each token will have 18 decimal places, and we will not have, I mean, in the background or behind the scenes, we are not going to have any comma, okay? Even if you want to send one token, even if you want to send half a token, you're not going to have any sort of problem with that. So here, okay, basically we are saying whoever is going to deploy this token is going to have is going to have 1000 of those tokens. So let's say you're trying to develop the next Dogecoin, okay? And you're the one, I mean, you're the developer implementing the smart contract. So when you're deploying that on the mainnet, okay, you're the one who is going to have 1000 tokens, okay? So in that case, whoever wants to buy 10 tokens from you is going to send you the money, you send them that tokens, okay? Or you can implement a function that will be in the sense of whatever money the contract receives, the contract is going to send a certain amount of tokens to that specific person. Okay, so in this case, we have mint. Message sender is going to have 1000 tokens. Okay, so just basically with those 6 to 7 lines of code, we have our token ready to be deployed. Okay, but in production, you can't just do this because you have to add other functions. Okay, like you have to add a function maybe to burn tokens, to send tokens to the person who has sent money and all. I mean, you can implement some kind of functions according to what you want, but in this case, we just need to have a token, right? We're deploying a token. That's it, basically. So we are just going to fix this small issue. I don't know what's going on, but we're going to fix it and deploy our first ever token. Okay, maybe let's put MIT for the moment. Okay, the error has gone. Okay, the error has gone. I don't know, I really don't know what was the problem right there, but okay, we have our contract ready to be deployed. So to deploy the contract, you just come to here to Solidity, and if you see this check mark, that means your contract has no issue or has no problem. Okay, and here you see the compiler is 0.8.7, and our Solidity version is, okay, 0.8 ish. That means it can compile. Language Solidity, compile a default, so the rest you can leave the rest as it is. So what you can do here is to compile. Okay, compile contract and wait for it. Contract has been compiled. So next step, you come right here, and this is the step where you're going to develop, you're going to deploy your project, or you're going to deploy your contract. So in this case, you're going to use the JavaScript virtual machine, because we can also use the injected Web3, but we don't have sufficient funds there for this purpose. But let's just use the JavaScript virtual machine, and here by default we have 10 accounts, and which account has 100 ether to pay gas fee. Okay, and we see gas limit here, and the contract that we want to deploy, this is where things, this is where you have to be careful. Okay, so we are first going to deploy, you can see a couple of contract there, but the contract we are deploying in our case is the my token. Okay, this my token dot sol. So we have my token dot sol right there. So when you click on deploy, okay, you just need to wait for it, and you see creation of my token pending. So that means this is currently being executed, and we just need to wait for it until that is done. Okay, Wait for it. I'm already seeing the deployed contract right here. We have a deployed contract. Just wait. So you see here, this is the deployed contract, and these are the functions that are public. Okay, public or external. That means the function we can access on that specific token or that specific contract. So this function, I mean these buttons that are in orange, means they change something on the blockchain. Okay, that means that you have to pay gas fee and so on. But these are the ones that are blue, they are just read. Okay, these ones read from the blockchain, and in that case you won't pay any gas fee. So to start off, let's read the name of our contract and see if we are going to get Merkim Dev. So if you read name, ooh, you get it, Merkim Dev. And if you read symbol, you get the symbol MKD, and it's MKD the way we have put it right here. And here, if you click on decimals, we see how many decimals, 18 decimals, exactly the way we have specified it right here. Okay, what else can we see? So now the cool thing here is you can check the balance of any account. Okay, if you just know the public address of the account, you can check the balance of that account. So in our case, we are going to check the balance of our message sender, the person who deployed our contract. And after checking this, we have to see that that person has 1000 tokens. And now, who is the message sender in this case? In this case, the message sender is this account that paid gas fee. Okay, so if we copy that account, okay, let me just copy and come back here to balance of, and I paste that address here. So we click on it, we should expect to see 1000. So if I see balance of, ooh, you see, believe me or not, this is 1000. Okay, and if you count those zeros, they should be now 21 zeros, because remember it has 18 decimal places. Now it's 1000. That means okay, what does 18 decimal places mean? That means one token, okay, or one MKD is going to be one with 18 zeros. Okay, and now if you say 1000, okay, it's going to be one with 21 zeros. And if you count all these zeros, they sum up to 21. Believe me. So guys, that's it. I mean, we are now having our token and all those stuffs, but now this, remember, we are using Ethereum IDE, so that means this token is only available in Remix. You can't access it from anywhere outside of that. But don't worry, just okay, we're going to do one thing. If you would like me to put another tutorial where I develop this and deploy it on a test blockchain, okay, just drop that in the comments below and I'll do that for you, for sure. So you just need to tell me, yeah, we need to see where you develop a contract, I mean a token, and deploy that on a local, I mean not a local blockchain, but a testnet. Okay, and we are going to deploy that on Mumbai testnet, so that you can access that even from your MetaMask, okay, and do something with that. So drop that in the comment below and tell me if that's something you are interested in, and I'll do that tutorial for you guys. So right here we have deployed and we have sent that money to this person. Okay, and here, okay, in the open Zeppelin, or in the this contract.sol, we have a method to transfer. Okay, that means you can transfer some of your funds to someone else. So right here, I'm just going to try, okay, I'm going to try something and change the account here. We take this account and I'm going to transfer 500 tokens to this account. Okay, and let's just see what is required here. So you get the recipient is this account, and the amount I want to transfer 500. So if I click transact, wait for it, we have here, we have an error saying the transaction has been reverted to the initial state. So ask me where this has reverted, and this is because up here, okay, up here, let me just check, we have changed the account, normally this is the account that has money, so you have to be on that account because that account is going to be the message sender. So right here, if I retry that, it won't fail. Actually, it's going to succeed. So if I transact again, woo, you see right here, okay, transfer value and all those stuffs. But if you check, let me just come back here and take balance. Remember, this is the account that deployed. It had initially these tokens, but if I click again of balance of, you see that has changed. That has changed, okay? And we are now we have transferred some token, and this has changed. So if we change this account and choose another account, a different account, the account to which we have transferred the money, we are going to see that that account now has 0.000005 something. Okay, let's change the control V, and when I call that function, you see it has 500 right here. You can see that, okay? And we have that the money you have transferred to this other account. And there are so many stuffs you can do with this, and you can add some functions here. Let's say function send funds. Okay, send funds, and this is going to be maybe this will take an address. Okay, the address where you want to send funds. Basically what I'm reproducing is this transfer method. Okay, this transfer, where is it, this transfer method right here. Let me just close it. I'm reproducing this transfer method, but you know, or with another name, and this will take an address called address, and it's going to take a uint 256 uint 256 amount, the amount I would like to transfer, amount. Okay, just amount. So here, what is required when you're doing this kind of stuffs, this is going to be public payable, because I want to access it out of this so that it gets shown here as public, and payable because I'm sending some ether, okay, or I'm sending cryptocurrency in that function. So here, all I'm going to do, this has to also be an address. I mean, yeah, just let me leave it as an address. And all I'm going to do right here is to require, first of all, before I send the money, I have to check that the person calling this function, or the other person who wants to send the money, actually has that money. Okay, because it doesn't make sense if you are trying to send the money that you don't have. So here we have a method called balance of, and I think it's right, yeah, it's right here, balance. We have balance of, no, balance of, and this is going to be the balance of the message sender, and message sender is the person calling this function. His balance should be greater, okay, this balance should be greater than the amount he's trying to send, and that's the logic. And you here, you can, if this condition is not matched, you revert that and you say insufficient found. Okay, insufficient fund, just like this, insufficient funds. And that means that that function will not execute if the balance of the message sender not is greater but is less or equal. Okay, if the balance is less or equal to the amount you're trying to send, that cannot go through because you also have to pay gas fee and all those stuff. But if you have passed this check, the next thing you're going to do is to call the transfer now. So you're going to call transfer, and this transfer method will hold this address. Okay, will hold this address just like this, and it's going to hold this amount right here, and we add amount. So that way, and remember, when you do that, you have to redeploy the contract again, okay, because you have to compile and deploy everything. So here, all I'm going to do is just to come here, contract token sol, and I deploy again. Okay, so now we have our deployed contract that we can interact with. So now, as you can see here, we have a function called send funds. Okay, we have a function called send funds. And if I want to send funds, I can't send funds to my own address. Okay, so the address I'm going to put right here. Let me just see how many tokens I have. Oh, just the account, just balance of this account, because this is the account that deployed the contract. So we see balance of this account. Okay, we have all the total supply, all the tokens we have minted right there. So all I'm going to do is to get another account. I get this account, I copy that account, then I go back to my initial account because it's the account that has funds. So I'm going to come here and send funds, and I put the second address and I put the amount. Okay, so I'm going to say 500 tokens. So if I transact this, you see the problem. We have an error right there. We say the transaction has been reverted with initial state. Reason provided by the contract, insufficient funds. So let me just see right here. They are saying insufficient funds, and I'm on the right account here. So we are going to know why they're saying insufficient funds, because I said balance of message sender should be no actually I did a mistake. So this condition, okay, oh my bad. So balance of message sender should always be greater than amount. So if that is not the case, you revert with this error. I just did the way around. But anyway, we all get bugs, right? We all get bugs in development. So I'm just going to do one more thing and redeploy my contract on this function, on that address. Okay, contract deployed. I come and pick the second address. I copy that address because it's the address I'm sending funds to, and I go back to my first address that has my money. And I think I deployed the wrong contract. No, it was the right one. So here we have that function called no, I deployed the wrong contract. Yeah. You have to be careful, guys. You have to be careful with these stuffs. And this is the contract I have to deploy, but I deployed the ERC20 from OpenZeppelin, but I have to deploy mine. So if I do the redeployment again, okay, we get it. I come back here, pick another address where I'm going to send the funds. Okay, address picked. I go back to my first address that has the funds, and I see my contract. I click on send funds. Okay, I send on that address and I send 500. So if I click on transact, guys, it has gone through. So let's just check the balance of the account where we have sent money, or we have sent ether, the second account. And as expected, before I click there, I guess you all know that we should see 500, okay, logically. So if I click balance of, ooh, we get 500 as expected. Okay, that means everything has just worked the way we want it to work, guys. Okay, so that's basically the deploying a contract for beginners. This is at the beginner level, but we have not gone deep into security, access control, and all those stuffs. But this is just so that you say, oh, I've also deployed my own cryptocurrency and it feels good. Okay, I know, because I also felt good after deploying my first cryptocurrency. But as I said again, guys, if you want me to do this and deploy this on a testnet, just drop that in the comment below, because right now we can only access this contract or this token from REMIX, and we can't access it out of there. Okay, so if that's something you're interested in, just drop that in the comment below and we'll work around about that. So guys, again, congratulations for deploying your first cryptocurrency. Okay, and you can name your cryptocurrency however you want. Feel free to change everything you want, the name, and you can also change the symbol. Okay, but guys, congratulations for doing this first milestone in deploying your own cryptocurrency. So again, thanks for watching. If there is anything you want to talk about, drop that in the comments below, or reach out to me on Twitter and we can talk about that and see how it goes. So guys, again, thanks for watching, and I'll catch up with you in the next one.